So we had OmniTek. So who are you?
Hello there, my name is Mike Hodson. I'm the president of OmniTek, and we're a company based in the UK, and we do two things. We do test and measurement systems for professional video, and we do development of IP cores and design services in conjunction with Xilinx. And what we're showing here at the OmniTek is a couple of things. We're showing some 4K images here. So this is the new coming standard for professional video and for consumer video. So we've got 4000 by 2000 pixels, and this application we're showing here is we're taking in some regular HD at low resolution, and we're zooming it up to 4K and filling the screen here. And we've got very high quality image processing. You can see that it's a very good quality image running in real time. And we're doing this based on two things, based on some firmware and some software which is running on this, which is our Zinc 7045 development kit. So this has got the Xilinx 7045 chip, which is got dual-core ARM A9 doing the software, plus a big FPGA based on the Kintex fabric. And this is doing real-time resizing of video in HD, and the software in the ARM is doing control of the hardware, and then it's also serving up a web page, which is shown on the laptop here. So here we've got a real-time interface, which is being served up as an HTML5 browser. And this eye diagram that you can see here is a representation of the serial bit stream that's on the video signal that's feeding the monitor. So this is a 6 gigabit per second eye diagram, and we're measuring in real time the rise and fall time of the bit stream. And this is being done entirely in the ARM processor in conjunction with the eye diagram in the FPGA. So this is our demonstration here for the OmniTek. It's a bit of ARM processing, a bit of video processing for 4K images, which is the new thing for the Christmas time in your shops.
So when you say Christmas time in the shops, does that mean what you do is consumer?
Yeah, well, this technology ends up in consumer displays. So the high-end television sets that you'll be buying in the shops will be using these resizing and de-interlacing algorithms that we've developed as IP cores, and have then been put into monitors by the likes of Sony and Panasonic and all the other companies like that.
So you develop upscaling technology for 4K, kind of?
Exactly, yes.
And that goes on the ARM solution inside the TV?
That's correct. Or the ARM will usually be doing the smart TV, doing all the control and the interfacing, and then the real-time video processing is done in this IP, which will be either as an FPGA solution around the ARM or as an ASIC.
So what is most common? FPGA or ASIC?
Well, this FPGA implementation is becoming extremely popular both in video and digital signage and other professional applications like digital imaging, broadcast video, and medical and industrial applications.
So here it looks kind of big, right? Is it because it's development right here?
Yeah, this platform was designed specifically as a platform to let engineers design their own algorithms. So this is a generic thing. It's got lots of different I/O formats that people need for when you're developing your own algorithms. What customers will typically do is they'll buy this board and they'll get all their algorithms working and doing all the processing they need. Then they'll reduce the design down to the core that they need and put that on a custom piece of hardware.
And so it'll be much smaller at the end?
They usually are, yes. Some people aren't worried about the size of this. Some people use all of the I/O that we put on there. But yeah, in many cases people will do their own stripped down design to minimize cost and make it small.
Is all the 4K upscaling based on ARM?
No, there are other applications as well, but the ARM is an ideal solution for this. I mean, we see in our customer base, which is mostly in industrial imaging, that the ARM is replacing embedded PCs now. It's such a better cost alternative. It's lower power, it's lower cost, and with the FPGA technology on there, you can do in a single chip, you can do what would take 2 or 3 circuit boards in an embedded PC architecture. So we think it's definitely the way of the future in industrial imaging.
And are you the best upscaling solution in the world?
I'd like to think so, yes. We've been doing this for a long time. So our background is in professional video, and we've been doing image processing, image enhancement for 20 years. So we think we've got some pretty good algorithms now.
But there's competition from Sony's solution or from other guys' solutions? Like
a lot of those guys buy IP cores from us as well. Yes, they develop their own ones, and some of them are very good indeed. But we keep abreast of this, and we like to think that we have the best algorithm development in the business.
And you said there was 2 things you were doing? The other thing you were talking about?
Yeah, so we're doing a little bit of test and measurement here as well. So what we do also at our company is we measure video signals and we check that they're legal to be broadcast by some of the broadcasters. So here we're measuring things like serial amplitude, we're measuring the jitter on the signal, we're measuring color balance in the signal, and we're measuring whether there's any errors in it. So we make products that do test and measurement on video signals for the professional environment.
What kind of usage is that? What is it for?
You'll find that these systems are used in broadcasters like CBS, Fox, NBC. All those guys will use our products to make sure that the signals that they end up broadcasting to the customer are all perfectly legal. They've got the right sound levels, they've got the right closed caption data, they've got the right brightness, the right color balance, all that stuff. So
There's law about that?
Well, there are industry standards, there are industry practices which are agreed, and in fact there is a law on loudness that's just come in recently to make sure the commercials aren't too loud compared to the video, and so there are accepted standards for a lot of this stuff, and we make equipment that monitors that and make sure it's within the legal range.
So what are you going to do in the future?
Well, it's interesting. So last week I was down at a conference down with the Society of Motion Picture and Television Engineers in Los Angeles, and there were some guys from NHK in Japan showing their 8K video system, which is 8,000 pixels by 4,000 pixels at 120 frames. And that system requires a bandwidth on the signal of 192 gigabits per second. And so that poses some quite serious challenges for FPGA and for processing design. So we're going to be looking at that in the future. That's where the video is going. Very high resolutions, very high frame rates, possibly even with 3D.
And 4K is so awesome and it's coming everywhere.
Yeah, 4K is looking really good actually. Not just 4K, but 4K at 60 frames per second, so you get a good update rate, great for sports, great for high resolution imagery. We're looking forward to it.
Is it possible to upscaling with like an HDMI dongle kind of thing?
Well, some manufacturers are putting that on the back of their TV sets, the ability to upgrade the software in your TV. And I believe Samsung has a dongle port on the back of their TVs that lets you upgrade them. So as long as your glass can support the resolution that's needed, you'll be able to support all the different standards in the future.
So your solution can be in something like an HDMI stick?
Well, possibly. We're looking at some things like that in the future.
And or is your solution just so perfect you never need to upgrade it? It's like
well, the standards always move on. And there's a lot of pressure in the industry to move to what they call this immersive imaging technology, where you get very high resolution, very high frame rate, to make it really feel like when you're observing a sports event that you're actually there in the theatre with watching the sports event. And so we'll be working to improve our technology to make sure that we're always at the forefront of all those developments.